Salut, aujourd'hui on reçoit Eigenlayer avec Matt et puis je suis accompagné de Patate Douce qui est très très fort en AVS donc qui est parfait pour le rôle. How are you Matt?
Excellent. How are you?
Very good, thanks. Et toi Patate, ça va? La
Très
pêche?
bien, très bien. Très content d'être ici. Très content de pouvoir parler de Eigenlayer et des AVS avec vous.
Yeah, we're very excited. Can you first introduce yourself, Matt, what you are doing to Eigen Labs, what are you working on, and what brings you to work on Eigen?
For sure. Yeah, we would be happy to. Yeah, I'm Matt. I am DevRel, EigenDA DevRel at Eigen Labs. Create Eigenlayer and EigenDA. And yeah, I am working with right now a lot of the rollups L2s that are building on top of EigenDA, as well as other use cases of DA essentially. And what brought me to Eigenlayer, I guess I'd heard of restaking and like DevCon, like Bogota, and it was just a weird abstract concept at the time. And then a couple years later, tried to understand how all these AVSs are coming together and what that actually means that they're building an AVS. And the further I went down the rabbit hole, really like excited me of what you can actually build on them and the variety and the scope of them. So combination of the people working on Eigenlayer and the problem space really attracted me. And yeah, been working here for the last bit now.
Okay, perfect. I think there is a lot of misunderstanding around Eigenlayer role. What is it doing? Can you explain a bit in high level, just for someone to be introduced in Eigenlayer work?
Sure. Yeah, Eigenlayer is a marketplace for building verifiable services. Maybe a step back. Essentially, to bootstrap and build services requires a couple different parties to be able to participate. And when I say these services, they often have some aspect of like crypto economics, a lot of compute, and often a decentralized network. Take, for example, Ethereum. You have a network that doesn't make sense that you want it to be run on one computer. It doesn't give you the properties to ensure that it's running and running correctly. So there's a couple things that are going on. There's this idea of like a proof of stake system where you have incentive to run, participate, and ensure that Ethereum itself is running correctly. And as well as you need a lot of people, a lot of computers around the world to essentially run this so that, if one computer goes down, the network doesn't go down. I think that's the beauty about a lot of these services when you hear decentralization is like resiliency and like verifiability, aka did the thing that happened actually happen? And looping it to Eigenlayer. Eigenlayer brings together like stake, so restakers. So the idea is that the core concept of Eigenlayer is that you are securing Ethereum in the proof of stake model. What if you can now secure additional networks and services? And a less abstract example is that if you're building an application on top of Ethereum, smart contracts, as an example, can only do so much. You need also additional services. As a basic example, you can't get access to outside information. And what I mean by that is I have no idea what the weather is on chain through a smart contract, let alone what prices are happening on other chains, whether these are L2s, other like L1s. You have no visibility outside of this little box that you're in. So you require things like oracles, maybe bridges, like co-processors as examples, maybe in the immediate term, as well as a wide variety of other services to essentially build full stack applications that get the guarantees that we like about, I guess, these decentralized like crypto applications, right? Permissionless aspects of them. So the idea is that you can not only just secure Ethereum, but it would be also more capital efficient and easier to bootstrap additional services that enable like full stack essentially applications across the board. And what Eigenlayer does is it enables that. It allows you to now stake and allocate that stake to additional services that require capital. So you have restakers as one sort of party, someone that decides to opt in and put stake within the system. You have operators. These are the ones that actually have computers that are trained and can run them. Anyone can join if you have enough compute and you want to run an AVS like EigenDA, you can spin it up and do that. And then the other piece is the AVS developers. So the people that are actually building AVSs. So these are like a variety of teams, including ourselves in the case of EigenDA. EigenDA is built as an AVS, and EigenDA is a data availability solution for Ethereum L2s and other use cases. And the sort of like premise then is like this other piece is that it's meant to enable full stack applications and experiences that like could not have existed, as now you can have, hopefully, I personally hope, like more sustainable like business economics around these. When you have the idea of better capital efficiency, you can bootstrap and run it out of the box a little bit quicker. And maybe to relate it to things that we are familiar with, like in AWS of the world, where I don't want to have to like write the code to like run a server myself and create my new my new data storage all from scratch. People who have specialized and created specialized services essentially allow you to be able to work on top of these abstractions. So we provide like SDKs, core infrastructure to be able to coordinate essentially between these parties of like stake, allocating that to operators, sending out the different like tasks that are required to run your service. And I view it very similarly as like kind of allowing us to have relatively like software as a service like models, but now on like Ethereum. So yeah, that is a long form version. And I gave up plenty there. I'm happy to dive into any part of that.
I think I got a lot of questions actually. I think there is a lot of advantage to use to be an AVS on EigenLayer. You need less token to bootstrap. There is a lot of advantage, but what about the premium? Some projects prefer to be an L1 because they got a premium exterior to EigenLayer. Do you think there is enough incentive for someone to be on an AVS, to build an AVS?
Yeah, I believe that what we're generally trending towards is a bit teams being more pragmatic and hopefully having like sustainable business models. And I think that the capital efficiency, the time to market that an AVS allows, as well as not having to rewrite a lot of really difficult parts of these systems. Like you could create a blockchain as an AVS. Like there are people who do this today. And as far as the premium goes, I think that there's always going to be incentives for different people to build different applications. I think that there is a very like large market of existing ones that we recognize. Like an Oracle is not a new concept. I think that there's also plenty of other services that will be able to be uniquely served on EigenLayer that couldn't exist elsewhere and maybe don't require actually the complexities of a blockchain. And I can give you one example of that is recently there's this project called Gas Killer and started a hackathon. And the idea is that on-chain can be very expensive when you're doing certain types of operations. Is there some way that maybe you can reduce the cost to, as this example, it's like you want to vote for a DAO. And if you have 1 million people in a DAO, how do you like go through, check like their weights essentially of like how much voting power I have within the DAO, and then like go actually log the DAO, the votes. What they're able to do like uniquely with like the AVS architecture is you have smart contracts on Ethereum and the code can be run like off chain. What they do is they can essentially simulate the Ethereum state to be able to like get all of these state values off chain. So instead of having to do it where it would cost way too much on chain. And then what they do is just update the individual storage slots that would be required. So it like minimizes the gas that you would use. And at like really large scale, they were seeing like 99% the gas efficiencies instead of having to do this on chain. So what I'm bringing that up is to your point of, do I see the premium as a whole, like there are going to be, probably continue to be, other teams that are launching L1s. I think that there's also a wide host of projects and problems that even if you launch an L1 need to be served. And like Eigenlayer is a marketplace for anyone to build these, and they can serve them. So like an additional, if it turns into additional customer, then maybe as well, right? Is that they probably require a bridge, probably require an Oracle. So I think that that's maybe also one way that I think about it, is there, there's more than one way you might interact with Eigenlayer.
Okay, great.
Nice. And currently, what's the business model of Eigenlayer?
Yeah, it's like the fees essentially, I believe, is like take a fee percentage from the operators that are operating the network. So like a certain percent for like an AVS essentially, that is like paid through. So similar to like a protocol fee that you would have on, like a DeFi protocol, like a Uniswap of the world.
Okay.
Nice.
Yeah. And so we have you have EigenDA. I think it's still the first AVS.
I think
What's
yes.
that? What do you mean by
AVS?
first?
With the most restaking on it.
Yeah.
Yes. Yeah.
Still, all right. So you have EigenDA, the DA layer of EigenLayer. What's the difference with Celestia? The well-known DA layer. I heard you got horizontal scaling, which cannot be done by Celestia. Is that true?
I can speak to EigenDA. I wouldn't want to speak to on their architecture on that front, but yeah, actually, so yes, EigenDA is horizontally scaling. What that means is like every additional node that is running EigenDA adds to the total system capacity. So it's a desirable feature. And maybe like to contrast it and give a quick intro is like on EigenDA, rather than every node having to store duplicate data and essentially like increasing the cost of that, and that would also reduce the like throughput of the system, which is really important for a data availability like service, is instead you do some erasure encoding, some like cryptography, create proofs essentially, and you like shard the data essentially across all of the operators of the network. So they're only storing like a very small piece of the data, and with the erasure encoding, we can then reconstruct it. So the like optimization that we're looking for is for Ethereum L2s, how do you optimize data availability beyond anything that is available? And this is the architecture that we've created, is this horizontally scaling, high throughput, like DA layer built as an ABS.
Okay. I got actually a lot of questions about the comparison with EigenDA and Celestia, because a lot of people are talking about Celestia. It's a bit in the middle of the narrative. But yeah, I heard a lot of interview with Celestia, and sometimes they say they got a premium over EigenDA because they say you act like a multisig, because you have more bandwidth, you're way faster than them. So that's they say that's their value. Do you think that's true?
Yeah, no, I don't think that's true.
No.
So I guess you have to apply it to what is the problem that you're solving for. So EigenDA is optimized for Ethereum L2s, and the guarantees that you get as a DA layer, when essentially, so I guess the guarantees that you get for a DA layer when you're working outside of the bounds of Ethereum, as far as security goes, you can't be posting directly to Ethereum. That's the most secure like layer that you would be posting to. The reasons why teams are opting to not is that the amount of data and the cost of it exceeds what they would like, essentially, right? So maybe you're not able to post like high throughput use cases, as an example. Like a mega ETH of the world creates too much data for it to actually exist on Ethereum, where it's roughly working on kilobytes per second. So that's just maybe setting the stage. And then everything that is external to it, you have very limited way to actually get that information onto Ethereum. And for all of these, it's like some sort of like bridging mechanism from you like end up getting a signature essentially. And what does that like signature or like metadata that you can send over to Ethereum represent? It essentially ensures that you did the right thing in your system. So for EigenDA, it's that all the validators like validated the data, they are like storing and ready to serve it essentially, and you get this DA certificate, which then can be validated by any of these rollups, like getting this sort of certificate that they are going to be able to retrieve it when they need the data. And that's also the same case for Celestia, is that for an Ethereum L2, the guarantees that you get is with a signature, essentially that's bridged over from the L1 of like Celestia to Ethereum is, hey, we did our Tendermint consensus correctly. So we ran our consensus and we have the data, like you can check the signature. So the guarantees that are compared when, I guess, when people talk about, DA and talk about like EigenDA or like Celestia as well, I think they're broadly talking about like some of the DA guarantees that maybe if you were to do like a native rollup on these chains, like you can be a rollup on top of Celestia versus our target use case is for Ethereum L2s, and we optimize for that. And the like external nature of all these DA layers to Ethereum, I don't think that necessarily gives like any premium to or guarantees to Ethereum L2s, really, because it's outside of the view of Ethereum as an example. And that includes with data availability sampling. That doesn't add any additional security for these Ethereum L2s in the sense that you can verify like maybe the data is like available, but like you don't get to go back and potentially they like slash from like an Ethereum smart contract where the attestation is actually posted, right? So you have like these isolated systems. You hope that they are working correctly. That is your promise that they are working correctly, and you'll post them to Ethereum. And yeah, I think that they have like amazing tech, right? On the premium side, I think that there's different things that people are optimizing for. And at the end of the day, these are all external to Ethereum. So it's sometimes blended as far as how people discuss what these guarantees are.
Yeah, I think it's very interesting. On every dashboard I found, there is only Celestia, blobs. Sometimes there is NeoDA, but I never found EigenDA because I guess MegaEth is not mainnet. So when do you think we can, have some level of comparisons? We can check a bit about bandwidth or that thing?
Sure. I mean, bandwidth wise, like today you can check that if like EigenDA is leading on that front at 15 megabytes per second of throughput. So I intend to scale that to 30 megabytes very soon, and 100 megabytes by the end of the year is the target. So on the system capacity, we've done stunts as well. If you want to check out EigenDA.wtf, we posted all the blocks from all the blockchains essentially. And that was roughly like 8 megabytes per second. And as far as like visibility into the network, that's something that we're working on. As far as we have an existing like blob explorer, it's equivalent of like a block explorer. And I would say, with like some upcoming or current teams, I guess maybe by the time this is live, like Mantle is already live on EigenDA, and like Avo as well soon. And next week we'll have a couple other launches, including Celo. So very excited. Celo, it's like switching from an L1 to an L2 is a massive undergoing. So I think then maybe to your question, you'll see you're asking around who's posting data, and those are some of the teams, and more very soon.
Okay, that's great. And I wonder, so there is a bit of FUD. I think it was yesterday or today about slashing. I think it's a guy from L2Bit that said that every data on EigenDA is not slashable, so it's not very secure. Where is I got a lot of questions about this. Where is the slashing mechanism on Eigenlayer? When is it live?
Sure. Like slashing on Eigenlayer broadly.
Yeah, I don't know if it's related, if it's the same, or yeah, it's both for both EigenDA
Sure.
and Eigenlayer.
Yeah, assuming the Cantina audit that is live right now, everything goes well. It's slated for April as far as slashing goes on Eigenlayer. And on EigenDA, we will be, so the slashing condition essentially is for a DA layer is like data withholding. You're trying to provide some disincentive from, if you want data to be available, the opposite of that is not making it available. How do you try to disincentivize that? And what happens if someone does? And there's no, so we will be using like eigentoken forking for this, as data withholding is not objectively provable. So versus I signed the same thing, twice. I can prove that, like that's on chain and I can very easily. But with data where like there's a lot of different factors to be able to check whether or not someone is actually maliciously not storing the data or serving the data. And you need some way to be able to check that. So we'll be releasing our DAS protocol as well as eigentoken forking. And that will be our sort of like, slashing conditions is in the case of a data withholding attack. If that were to happen, you can do that. So I guess to address what you were maybe bringing up, let's see. So on your first point, maybe as far as like slashing and what is slashable, I think that is, that's what you're referring to is like the like definition that L2B has as far as economic security refers to slashable stake. And because data withholding is not like an objectively provable like fault, you can't slash. We have ETH quorum, so we have like over 4.3 million ETH that is staked on an EigenDA today, and then you have the Eigen quorum. And essentially, the way those systems work is they get sent to both of these. Within each of these, they have to have stored it, and it's like a sets of operators that are storing that. And I think what he's essentially referring to is that you don't have the ability to slash on data withholding. And how does that compare? I think that is like one. I would push back that there is economic security on that front in the sense of like a Byzantine like fault tolerant. So like picture Ethereum, like I'm talking about, let's say the cost to corrupt it. Like one way that you would have that is there's typically like a honest majority assumption. I hope that majority of people are honestly running the service, and if not, then some of the breakdowns or some of the like things like consensus or like could start breaking down and things happen that you don't want to have happen. So what that means is on the flip side, roughly like 1/3 of the network would be required to corrupt the system. So for EigenDA, so how that would work is on Ethereum, take the cost, take how much stake is on Ethereum, times it by like roughly 1/2 or 1/3, plus probably some other factors of like how do you actually coordinate and get that capital. It's not a direct one-to-one as like what the actual cost is, but that's roughly is like 1/3 the cost of the stake you'd be able to corrupt it. And in the same way, for EigenDA, we uniquely have this like concept where we have multiple quorums. So now it'd be like 4.3 million ETH times like 1/3 plus the cost to corrupt like the Eigen quorum or an additional quorum that we allow like other rollups to also select if they want their data to be sent to those. So maybe that's some context as well on that.
Yeah, a lot of context. That's perfect. Thanks. You talk a bit about native rollup. I'm not sure to have understand. I'm really interested in native rollups. There is very few content around it. So you said they can use EigenDA as a solution?
So I guess when I said native rollups, I was meaning like native to an ecosystem as far as like like you're settling on Ethereum as an example, and like that's like native versus like everything being executed essentially on it.
Okay.
Okay, perfect. Let's talk now about the other AVSs. First question: Can we deploy an AVSs without the permission of the Eigenlayer team? Because during the last ECC, I was talking with someone from Lido, and I asked what's the difference between Symbiotic and Eigenlayer, and he told me you can deploy your service on Symbiotic without the permission of the team. That's correct or not?
That's incorrect. Anyone can deploy a service. If you wanted to, you could go and deploy one right now yourself. You can stake any asset. That can be any ERC20 beyond just ETH. That's permissionless. Eigenlayer, EigenDA are permissionless.
Okay.
So yeah.
Okay, nice. What do you think AVSs are mostly secure, specialized, or B2B blockchains, and not layer one generalist, for example?
I guess you could that is something that you could probably build. I am not as familiar with how like you would build the consensus of like an L1 as an AVS, but I guess like the reason why is that maybe like why are we seeing on the flip side more of these other services is that these are like existing parts of the stack or existing like problems that people have as far as the current market, rather than maybe like potentially creating a whole new chain. So I think that there's plenty of opportunity in the existing like market as far as like servicing that and then creating new services to enable that. So like there's like a wide variety of different ones. Like you've got, I guess upcoming as well, like let's say CAP, which is a yield bearing stable coin. And they're essentially like using that, like the stake on Eigenlayer as a way to incentivize people to like earn yield for the stablecoin holders, or something like a predicate where they do policy checks essentially prior to transactions. So as you move to maybe like having better selected set of users for certain like services, or like who can use a service, and like how do you create maybe like specialized experiences for types of users, they like generalize essentially these like pre-transaction checks like out of the box. So I think that there's just a lot of design space that is to be handled. So would welcome someone if they want to build an L1. if they want to try, I have no idea what that would actually look like in practice. But also I would say we're seeing a lot more L2s launching than L1s. And that's definitely rapidly accelerating with RASs and like generalized rollup stacks.
I wonder if we love Eigenlayer. We really love it because we find it everywhere. Everywhere I search a white paper, there is Eigenlayer in it. I think it's really great solution, but maybe it lacks some visibility. A bit like Ethereum with layer 2. It get a bit too much behind. Do you think that's a problem on the long term, just so people get aware about everything you do?
Yeah, that's a great question. I think it's a really hard problem because there's like a wide variety of projects that are built. Like you have this base layer essentially of Eigenlayer itself, and then you have now all these like sprouting ecosystems that are like not running wild, but like how do these connect to Eigenlayer? And I think that's awesome because this is like infrastructure that should be like helping to power these services and should be like kind of behind the scenes, like making these things possible. But yeah, I think it is a difficult problem to try to figure out. How do you connect all the dots? Like how are all of these things related? And do you need to like how do you explain that is like related? How is someone using Eigenlayer from a variety of these services. Like I mentioned, like Gas Killer as an example, which like started as a hackathon project, and it's like a really interesting, unique design to like teams that are building like full-fledged networks and like proving networks on top of Eigenlayer. Those don't look the same. So I think it is definitely a difficult problem for people to be able to understand it. And we're definitely trying to make steps to improving that, and like have to be like conscious about how you connect the dots, and like you kind of have to like repeat yourself as well. So even just the fact of, let's say, restaking being Eigenlayer is a tough one, right? It is like restaking is like a means to an end, and that is like powering these new services. But still, a lot of people like just immediately think like Eigenlayer restaking versus like Eigenlayer, these are services that you're like building, or like I hope it kind of just turns into like, oh, these are applications that under the hood are using services that happen to be powered by like AVSs. So one thing that we've actually tried to do to improve this is like it's like the Eigenlayer economy. I think it's economy.eigenlayer.xyz, and it shows what's going on within the space from like a metrics, like a dashboard sort of view. So we have to be definitely conscious, and I think hopefully do consistent, like better jobs, and hopefully I can get around and do more succinct explanations of what Eigenlayer is or any of these concepts. But yeah, like I feel like things like these are really helpful as well.
Yeah, it's a hard problem, definitely.
And in the same way, that's why recently Eigenlayer bootstrap Alpha Eigener to get more KOL or people to create content around Eigenlayer. It's a way to solve this problem, I think.
Absolutely. Yeah, there's a lot of different, like how do you reach people where they are and also like enable or empower them to do so? And yeah, so like the Alpha Eigeners like program is our ambassador program that we're rolling out that you're alluding to. So I think that that's a great way to be able to better sort of like spread your like information in the sense that you get like very passionate people who are like have like a community that they are already are able to speak through like their lens, right? It's like there's not going to be one way that you understand a concept. So I feel like empowering people and like also providing like direct lines of contact with the team is a great way to be able to do that. So I'm excited to for that to continue to roll out.
Okay. You know, I made a whole episode on all AVS on Eigenlayer. It was like, I don't know, maybe 90 or something like this. There is a lot more now. There is a lot of variety of AVS, a lot of services. What are the one you are the most excited about?
Sure. Yeah. I mean, I like consistently go back to ZK TLS, and like we've got like two teams that are building this, Opacity and Reclaim, and like actually that's how I started to go down and like had a really big light bulb moment, was finding out how like Opacity was going to be built as an AVS. I was like so ZK TLS essentially is this concept that you can prove any web data, essentially picture like any API or like any website behind the scenes served over TLS, and now you can prove information. As an example, maybe you can prove a bank balance. And a more like useful example of that is maybe like Earnify, which is like it's a Apple App Store. Apple App Store. It's a iPhone app, and it's meant to do like payday loans, essentially, that I don't have access, I don't have money today, but you can prove that I have like reoccurring revenue, essentially, or income from my employer, and I can use that as a way to get like a loan ahead of my payday to maybe pay bills or things like that. And I think that's like a really interesting like use case, as well as there's just a wide variety of use cases where you want to prove something from one of these like information silos that exists online. I still am hoping that someone builds something for like apartment proofs as far as when the whole apartment process is so broken, and having gone through it not too long ago myself, I have to provide all of my financial history, anyone maybe that's related to me, and other like any sort of piece of information, let's say like employment, all of these things, and it's like I'm just sending a PDF. It's like, hey, I really hope you don't just like, I don't know, print out all this information wherever it goes on the backside, versus someone wants to just be able to check and ensure that I can pay rent and I will be like good for it and have some history of doing that as well. And I think that gets into like this category of like ZK, and like ZK-TLS is sort of like I would say, I don't want to say like a minor use of ZK. It's not like a complete ZK when you're talking about like ZK proofs or ZK VM. It just allows you to potentially like selectively disclose information where, I can prove that I have $100 in my bank account, but I don't prove that how much I have, right? I have more than X dollars. So for me, like, I think that's a really interesting design space, and you're seeing a lot of applications that are built where you don't know that it is using ZK. And I find that really exciting. Is like, that's the way that any of this will work, is if it creates better or new experiences. And I'm excited about that. And for myself, like, it was a light bulb moment when I was talking with Hirsch on Farcaster. It's like, I had been going down the rabbit hole and of Eigenlayer and what an AVS actually could be. And like going back about ZK-TLS, maybe around this time, like last year, it's like, could you build this as an AVS? Like, should you build it as an AVS? And he like sends me back his HackMD, which documents his design for it. And I remember like just being in my bed and being like, oh wow, like this is real. like this can actually. So yeah, I think that's a really exciting design space.
Okay, I think there is already a project that uses this 3Jane. All the information can be retrieved to trace it back, right, on 3Jane. Is it possible with ZK-TLS or not at all?
I don't know exactly like what information. Like, I'm less familiar with their actual like, app implementation. But maybe if you were to have something where, let's say in the US we use like Venmo for peer-to-peer payments, hypothetically, and like you could check and prove whether or not a transaction went from like Matt to you with a certain amount, and then if it didn't happen in this predefined time frame of, let's say, I expect the debt to be paid back in a month, like you could do that. It's like something that ZK-TLS would allow you to do, is like prove whether or not that transaction had happened, and ensure that hopefully someone is getting paid. But I don't know the exact implementation on 3Jane, so I'll have to try it out myself.
Okay, nice. And recently, I saw a paper called Verifiable Agent Framework. Can you quickly explain what is the Verifiable Agent Framework, and why Eigenlayer puts a focus on the AI side?
Sure. Yeah, on the Verifiable Agent Framework, there hasn't been really a concept of like verifiable agents as a whole, and the idea there is like with AVSs or services that are built on top of, like, let's say, services that are built on top of Eigenlayer are like verifiable in the sense that I like the term like more commitment. Like verifiable is more like, hey, I can check what is being done, but I like the term more like commitment, as far as I say that I will do something. And for example, an agent, the base case that someone uses is a trading agent, where agents are wild in the sense that they're rapidly accelerating like what you can sort of do just in general, or maybe that's more broadly, let's say, AI. And the traditional or early use case a lot of people talk about is trading agents, where they can have all of the market information from across a bunch of different chains. And I essentially want them to be like trading on behalf of me. I give them some money and I say, please make me more of this. And I hope that you do that. But there's probably so that's just, you kind of like can set them loose, and now they'll start making decisions and transacting on your behalf. So the intention is that, I would like you to make more money, but I probably also have some other things that are in mind where like maybe there are certain like when money is at stake, I guess, first of all, you want to ensure that it is being handled correctly. And like the steps that you would like the agent to take, maybe you have it programmed to look at certain protocols or certain, like you have a certain risk appetite. And how do you actually ensure that it is making transactions that like fall within those certain bounds? Is like, it's kind of just like let loose, right? And the interesting idea with like crypto economics or these services that are built as AVSs and this verifiable agent framework is like proposing even a framework for how do you consider what like verifiable agents would look like. And the first level that proposed is that these are that they use when they're doing this. I like mentioned looking at like price feeds as an example. That's like a core thing that you'd want it for trading. That has to go through an oracle, and that's like one tool call that an agent will do. Like it will reason, and then it's like, hey, I need to understand the prices. And the verifiable like agent like framework is this idea of like, how do you ensure that like, like I got the price and the price was interpreted correctly, it was executed as I expected, and essentially ensuring that from like intention to actual execution, those things are done correctly. So the first level that was proposed is that these are when they are doing these tool calls, they are using an AVS, as you can have like strong crypto economic guarantees that when a service, like one part of its execution is done, you can have a strong assurance that that part is done correctly. Like an oracle call is done correctly as an example. So I think that that's like the broadly sort of the verifiable agent framework is introducing even a concept of verifiability with agents, and maybe like more broadly also AI. So your second question was on agents, or just more broadly like AI and like why that is of interest. So I guess it's very similar sort of like line of thinking is that like AI is continuing to expand like the possibilities of what you can do as a whole, and there are both like services that are required to be able to like power these these networks, maybe as simple as just like compute networks, and you need more compute. One of the examples of like teams that are building services today that will be used by an AI developer, it's like a part of their like maybe like model creation, like the actual like model deployment or like refining is like compute. Like I need to send it somewhere so that they can actually use these like I need GPUs, and that can be very easily built on top of Eigenlayer as an AVS. But like more broadly, there's like things that power these, and as far as like required to build AI with like strong guarantees of ensuring the things that you're expecting them to happen. And then the other side is like actually building out AI in a way that like aligns with your expected execution, or your intention essentially with it. So we'll be releasing more of that soon as well.
Really?
So yeah.
All right. That's perfect for my next question, because I want to ask you what you're the most excited about. I don't know, EigenDA side or Eigenlayer. What are you waiting for 2025 the most?
Yeah, I'll go outside of like the bounds of maybe like what Eigenlayer itself is working on. I'm really excited about hopefully using some more applications that people are building from AVSs. I think we just went through last week of like teams that are using AVSs like under the hood, and it was I can confidently say it was like above like 50 plus like different applications that are like live in production. I think it was close to like 80 almost. So I think that is something that personally I'm very excited about. Is at the end of the day, I want like crypto, or more broadly like the internet, to be like useful and used for things. So having AVSs now like not just exist, but like deployed and being used by developers in cool like creative ways, I'm personally very excited for that, like the AVS consumer side to grow.
And for EigenDA, what is plan? You said 100 megabytes for this year, right?
Yeah, that's the target. Yeah. Like, what am I excited about on EigenDA? It's like a similar thing. It's like now seeing what applications people are going to build on top of these different chains, right? So like now you built the thing, people are using it. How are they using it? Is for me, like that's like very motivating, and I would like to see like creative uses of DA, and I suspect that we'll see a growing category of use cases that are like non-rollup, like more like general, whether these are AVSs that are using DA or like applications. So I think there should be some like pretty unique constructions there.
Did you try MegaIf?
That is on my to-do list for today with the testnet.
Yeah, you should.
Yeah, you should. That's crazy. You just did
Yeah.
your transaction. It's like blinking. That's so fast. I tried the Monad testnet. I was that's fast. That's cool. The experience is good, near to Web 2. And this morning I tried the MegaIs, and that's crazy. That's too fast.
Yeah.
It's too fast.
Too fast for me.
Faster.
Too fast for me.
I don't have a lot of questions. I just have 2 more questions. First, is there something we missed you want to talk about?
I think I appreciate the variety of topics as well you covered. Now I feel like that pretty much covers most of it.
Okay. Yeah. Okay, good. I have a question, but more for Matt than for Eigen. Usually we ask everyone a bit of advice, for someone that is interested in crypto or want to work in crypto. Do you have a piece of advice from your experience?
It's a great question. Like I really appreciate that question because I feel like I would have loved to hear it myself. I mean, yeah. I don't know if it's like don't be shy, but like it's probably like think in the open, in the sense of like, I think the biggest benefit of crypto, like the big thing that like keeps me very interested and first attracted me is how open people are to share, and everything is constantly evolving. So like you kind of have to learn. So everyone is constantly learning. So don't feel afraid to do that. I would probably recommend, trying, find some people that you maybe are interested to like learn from, go deep on something, but like put it out there. I think that like maybe more so my advice is write and like put things out there and like have discussions with people. I think people are very, very open, and that's a big like value that I really appreciate in crypto as a whole.
Yeah, same, definitely. Okay, perfect. I would just, turn back in French to address to my community. Merci d'avoir regardé l'interview, c'était vraiment top. N'hésitez pas à rejoindre le Discord si jamais vous avez des questions, et si jamais vous voulez en apprendre plus, que ce soit sur Eigenlayer, EigenDA ou tous les AVS, je vais laisser la parole à Patate qui s'y connaît mieux que moi, si tu as des sources.
Bah, dernièrement, il y a moins d'un mois, j'ai lancé un compte nommé The Daily AVS qui fait une sorte de thread récapitulatif de toutes les dernières news des AVS, outre parce que les news autour des AVS sont fragmentées, un peu comme la liquidité sur les L2, malheureusement. Donc je recentralise tout ça. Et il y a 2 autres comptes qui apportent énormément de valeur aussi. C'est Coordinated. Eux, ils font ça, mais de manière weekly, et ils balancent énormément de podcasts et de contenu autour des AVS. Et il y a Restaking, qui lui, c'est plus un point de vue global sur tout ce qui se passe autour du restaking, que ça soit Eigenlayer, Symbiotic, Babylon, voilà. Bien sûr, tout sera mis dans la description. Les comptes que
tout le lien dans la description. Et puis le lien Discord aussi. Thanks a lot, Matt, for coming.
Thanks.
Really appreciate.
Yeah,
and,
thank you very much.
Yeah. I hope the best for EigenDA and for EigenLayer, and maybe see you, I don't know, one day. I hope.
Yeah, that'd be great.
See you, man.